Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody, and welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And I just love what we get to do, which is sit here on Wednesday nights and just do math problems together. It's to help you build your confidence and your competence in that math skill set so that you can go into that test ready to go. We will be going over K through 12, pre-K through 12 problems tonight. But if there's something specific that you're like, man, I really wish she would have gone over parabolas, or I really wish she would have gone over some more geometry specifically tailored for K through 6 or something or if there's a specific question, do not hesitate to comment and let me know, or find me on Facebook and let me know, because these sessions are for you. And so if there's something that you specifically need, just let me know. I am happy to help. A little bit about me. I am from Central Florida. I've been in education for about 15 years, and I am currently an assistant principal of a middle school and high school. So before I get started, I always like to do a little get to know you question. It makes it feel a little bit less like a computer screen and a little bit more like we're doing math together in the same room. So in the comment box, let me know where you're from, what test are you prepping for, and what has been your favorite summer memory so far this summer? Where are you from? What test are you prepping for? And what has been your favorite summer memory so far? I think my favorite summer memory has been kayaking with my little one down the Weeki Wachee River. It was so fun. And I have not been kayaking very often. And so that was so fun and just something out of the ordinary than what we normally do. So that was probably my favorite summer memory this summer. I do want to say we are well aware that our website was having some issues this week. Hopefully it has been resolved for most of you, but if it has not been, I apologize. We apologize. It's definitely it's not an us problem. It's our cloud issue. But Dr. A has done a great job communicating via email and Facebook, trying to make sure that everybody still has access. So we are sorry that has happened. It's definitely out of our control. It's definitely not typical. So thank you for bearing with us and understanding, even though it is frustrating, and we get that. All right, so let's go ahead and jump right into our first problem for the evening. A picture is to be printed onto a sheet of paper with dimensions of 8.5 by 14. A margin of 0.75 inches is to be left on all sides of the picture. What is the area of the painted picture, the printed picture? What is the area of the printed picture? So this is a geometry problem, but it's not your typical, a rectangle has a width of 4 inches and a length of 8 inches. What's your area? Which is a very level 1 DOK level problem. This one requires a few more steps. It's a multi-step problem. Anytime we are dealing with geometry, and you'll hear me say this over and over again, anytime we are dealing with geometry, it's always a good idea to draw that picture out. So a picture is to be printed on a sheet of paper. I'm going to draw my sheet of paper, 8.5 by 14. There's my rectangle. And we're looking at dimensions of 8.5 by 14. A margin, which just means the outside of the paper. I'm trying to see if I have a piece of paper here. Here's the back of a binder. We can use that. If this is my sheet of paper, the margin is that area of space that it's not printing within. You know, like sometimes when you're in like a document and it's like outside of the printing range. So the printer can't print all the way to the edge of the paper, but you can tell the printer, I want a margin of 0.75 inches. I want a margin of 1 inch. I want a margin of 2 inches to narrow out what the printable space is on your paper. So a margin of 0.75 inches is to be left around the whole thing. It's like a border or a frame. It's like a border or a frame. So now I'm going to go in and create the actual printable area of my picture. So here is the printable area of my picture. So the ink is going to stay inside this border. So there's my printed picture. And it said that this right here is 0.75, and this right here is 0.75, and this right here is 0.75, and this, it's all 0.75. So they are asking us, what is the area of the printed picture? So they want the area of just this pink rectangle, which is just a length times width problem, right? Area equals length times width. I just have to figure out what that length and width is, because it's not 14 and 8.5. It's not 14 and 8.5 because I'm getting rid of this white space that's on the bottom, the top, the left, and the right. So what is that printable area? Well, if this whole thing is 14, and I know that this little section is 0.75, and this little section is 0.75, what do I need to do to figure out what this length is? I can do 14 minus 0.75 minus 0.75. I'm going to use my 4-function calculator. Not everybody's going to have that, and that's okay. 14 minus 0.75 minus 0.75 equals 12.5. So the length is going to be 12.5 times something. I'm going to do that same process over here. So if I know that this whole thing is 8.5, and I have 0.75 here and 0.75 here, I can do 8.5 minus 0.75 minus 0.75. 8.5 minus 0.75 minus 0.75 is 7. Now I can go ahead and find the area of my printed picture. 12.5 times 7. Now I could use my 4-function calculator. I'm going to show you how to multiply without my 4-function calculator. When we multiply, we do not have to line up those decimal points. When we multiply, we do not have to line up the decimal points. When we add and subtract, we have to line up those decimal points because we want to make sure we're adding apples to apples, oranges to oranges. But when we multiply, we don't have to do that. 7 times 5 is 35. 7 times 2 is 14, 15, 16, 17, because we add that 3. And 7 times 1 is 7, plus 1 is 8. And I have 1 space to the right of the decimal represented in my problem. So I'm going to have 1 space represented by my decimal in my answer. So 87.5 inches squared is my answer. Questions? All right, let's go ahead and move on to problem number 2. Sabrina knows that she can paint a rectangular wall that measures 8 feet by 12 feet in 1.5 hours. She estimates that it should take her about 3 hours to paint a rectangular wall that measures 16 feet by 24 feet. Is Sabrina's estimate reasonable? Is Sabrina's estimate reasonable? Yes, because doubling the size of the wall will double the amount of painting time. No, because Sabrina will be able to paint a longer length without changing direction, resulting in a shorter painting time. Yes, because when the perimeter of the field is doubled, the total distance that she is painting needs to be doubled. No, because doubling the dimensions of the wall will increase the area of the wall by 4, resulting in a painting time of about 6 hours. All right, so this is a really, really wordy problem. The best way to do it, if you read all of that, now, being someone that knows math like the back of my hand, clearly, I can read that and figure out what the answer is. However, many of us cannot. And there are definitely problems that I should be able to and I can't. So here's how I would figure it out. I would do the area of my first wall and figure out what that is per hour. So I can do 8 times 12 equals 96. So she can paint 96 feet squared in 1.5 hours. That's like her standard rate. Now, when I do 16 times 24, I notice that the dimensions are doubled. 8 times 2 is 16. 12 times 2 is 24. 16 times 24, I'm going to multiply that out here. 4 times 6 is 24, carry the 2. 4 times 1 is 4, plus 2 is 6. Placeholder 0 because I'm moving 1 place over. 2 times 6 is 12, carry the 1. 2 times 1 is 2, plus 1 is 3. Add them together. 4, 8, 3, 384. Now I'm going to just check that with my calculator real quick. 16 times 24, 384. Now, 384 is very clearly not 96 times 2. 96 is almost 100. So 96 times 2 is going to be almost what 100 times 2 is, which would be 200, right? 384 is way, way, way off of that. So it's going to take her longer than 1.5 hours times 2 to paint this wall. So no, her estimate is not reasonable. It's not going to take her about 3 hours to paint this wall because 96 in an hour and a half, if I was going to double that, I would have to do 96 times 2 and an hour and a half times 2. And that's not reasonable, right? Like 96 times 2 is not 384. So, and my iPad just disconnected, but I don't know where it went. So I'm just going to unconnect it and reconnect it. So then I can automatically cross off my 2 yes answers. I have a yes on the top and a yes in the middle. A and C are both yes. It's not a reasonable estimate. Now I just need to figure out why it's not a reasonable estimate so that I can choose the correct answer. I'm waiting for my iPad to reconnect. Reconnecting. It's trying. Sometimes I have to force quit my app and then like go back. Okay, let's try this again. While we're waiting, I want you to think about some things that you're like, man, I wish she would go over this. What is that thing that you're really wishing that I would go over? I want you to think about that and let me know in the comment box so that I can make sure to include it in upcoming sessions. All right, here we go. Here we go. Here we go. Here we go. Go, go. Here we go. Okay, so it is not a reasonable estimate. That's what we've concluded. So no, it's not yes, right? So no, because Sabrina will be able to paint a longer length without changing direction, resulting in a shorter painting time. It's not going to be a shorter painting time. She's almost, if not exactly, quadrupling the amount of area that she's having to paint. So the dimensions, even though she multiplied the linear length by 2, because each of those was multiplied by 2, it's going to quadruple the amount of space that she has. 384 divided by 96 is 4. It's quadruple the amount. And so the painting time is going to be 1.5 times 4, which is about 6 hours. So the answer for this one is actually D. Now, this goes right back to scale factoring. This goes right back to scale factoring, and it's definitely something that you'll want to be familiar with. All right, let's move on to problem number 3. A student says, this is a triangle because it has 3 points. The shape the student is pointing to has 3 points, but 1 curved side. What should the teacher do? Agree, because all shapes with 3 points are triangles. Explain that triangles must have 3 straight sides and be a closed shape. Ignore the misconception to avoid confusion. Or tell the student that points are more important than sides. So the student says, this is a triangle because it has 3 points. But the shape that the student is pointing to, it does have 3 points, but it has 1 curved side. So it might look something like this. Here's the 3 points. It might look like that. It could look like this, or a variety of things, right? What should the teacher do? So the teacher's not going to agree because that would be false. Neither of those shapes are triangles. All shapes with 3 points are not triangles. And even all the way down to pre-K and kindergarten, we have to be careful with our language when we're telling students these kinds of universal statements. We have to be careful to not say all shapes with 3 points are triangles or all shapes with 3 sides are triangles, because that's not true. All shapes with 3 vertices and 3 straight sides that are closed are triangles. But this is a 3-sided thing, right? But it's open, so it wouldn't be a triangle. So we have to be careful and precise with our language to make sure that we're not overgeneralizing rules for our students. And we think that they don't notice in kindergarten, and they may not be able to verbalize it, but they absolutely start to put those generalizations together. Ignore the misconception to avoid the confusion. We're definitely not going to ignore that misconception. It's a teaching opportunity. Tell the student that points are more important than sides. That's not true. Points are not more important than sides. And so we don't want to tell them that either, because if points were more important than sides, then both of those would be triangles. We want to explain that triangles must have 3 straight sides also and be a closed shape. And we can model that for students. We can show them examples and non-examples and have them notice similarities and differences between those and kind of discover that on their own and then realize, oh, that's not a triangle. So all of that said, B is going to be the correct answer in this case. Let's move on to problem number 4. Now, problem number 3 was absolutely a pre-K through 3, like teaching pedagogy problem. Problem 4 is also going to be a pre-K through 3 problem, and then we'll jump into some other stuff. Alana's teachers asked her to count out 4 red counters. Alana counted 4 counters. Then Alana's teacher asked her to add counters to her pile of 4 so that the pile would have 9 counters. Alana counted out 9 more counters and added them to the pile of 4 counters, resulting in 13 counters. Which of the following most likely explains the reason behind Alana's error? Alana does not fully understand one-to-one correspondence between numbers and objects. Alana does not yet know her addition facts for sums greater than 10. Alana does not yet understand the quantity of 9. Alana does not yet understand that one quantity can be composed of 2 smaller quantities. All right, this is a fun problem, but it's very wordy. These teaching pedagogy problems are often so wordy. So let's break down the scenario first and then figure out what the error is. So Alana's teacher asked her to count out 4 red counters. So I'm going to pretend like I'm Alana and I'm going to count out 4 red counters. 1, 2, 3, 4. Okay, so Alana has 4 counters, right? Here's her 4 counters. Then Alana's teacher asked her to add counters to her pile of 4 so that the pile would have 9 counters. So now I'm going to do that. I'm going to add counters until I have 9. So 4, 5, 6, 7, 8, 9. So I added counters to my pile of 4 so that I have 9 counters. Alana counted out 9 more counters. So she had her 4 counters, and then instead of counting out counters until she got to 9, she then added 9 more counters. So this is the correct teacher response, and this is Alana. Now we can kind of compare and see, right? Resulting in 13 counters versus the 9 that the teacher wanted. What explains the reason? She does not understand one-to-one correspondence between numbers and objects. That's not true, because she was able to count the 4 counters. She was able to go 1, 2, 3, 4, and then she was able to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and able to say she has 13 counters. So A is not correct. Alana does not yet know her addition facts for sums greater than 10. That's probably not the correct response either, but we're going to leave it. Alana does not understand the quantity of 9. Well, she probably knows what 9 is because she was able to count to 9 and then beyond. So I'm going to cross that one off. Alana does not yet understand that one quantity can be composed of 2 smaller quantities. There it is. Why is it that complex long one? Because the teacher asked her to start with 4 and then add some more to equal 9. Alana doesn't realize that 4 plus something can equal 9. That one quantity, 9, can be 2 smaller quantities because they said, wait a minute, you need to add the 9. She thinks I need to add 9 to my 4. She doesn't realize that 9 can be 2 separate quantities. So that would be the correct answer for this one. That was a fun one. Let's move on to problem number 5. Two angles are complementary. 2 angles are complementary. One of the angles has a measurement of 54. What is the measurement of the other angle? What is the measurement of the other angle? So for this one, we've got to know our vocabulary, middle school and high school, GK, Praxis core people. We got to know our vocabulary. 2 angles are complementary. Complementary angles, vocabulary lesson here, are angles that equal or whose sum is 90 degrees. Or when you add them together, it equals 90 degrees. Now, does it have to only be 2 angles? No, it could be 4 angles are complementary. In this case, it was 2 angles are complementary. One of the angles is 54. So angle plus angle equals 90. That's the scenario we're working with here because these 2 angles are complementary. One angle has a measure of 54. 54 plus something equals 90. Following me? So when I look at my answer choices, fun fact, I don't even need to do this math because this question is completely a vocabulary question. This is why you want to read your answer choices before you start to solve it because you could waste a lot of time solving a problem when you don't even need to do that. 36 because the sum of 2 complementary angles is 90. 126 because the sum of 2 complementary angles is 180. 306 because the sum of 2 complementary angles is 360. Or 54 because complementary angles are congruent. Do I need to do any math here? No, I don't need to solve this problem because only one of these gives me an option for complementary angles to equal 90 degrees, and that is A. So I don't even need to solve 54 plus something equals 90, subtract 54 to both sides and figure it out. I can just use my answer choices and say, hey, I know what the definition of complementary angles is, and that's 2 angles who equal 90 degrees. Now, supplementary angles equal 180 degrees. So just a little vocabulary lesson. Supplementary angles equals 180. And a circle equals 360 degrees. And congruent angles are congruent. Complementary, supplementary, like none of that's congruent. It's just congruent angles are congruent. All right, let's go ahead and move on to problem number 6. You're doing a great job. What is the measure of angle C? What is the measure of angle C? This one is a fun little algebra problem. So I know that I am looking for angle C, which is down here. And I want the actual measure. I'm not looking for X. I want the full measure of angle C. I know that this angle is 47. What else do I know about triangles? The sum of the interior angles of a triangle equals 180 degrees. So A plus B plus C equals 180. So let's fill each of those in. 47 plus B plus C equals 180. Now, this looks like an algebraic equation that we can solve. Combine like terms, get the x by itself, and you know what to do. I'm going to combine my like terms, so my x terms together, and then all of my constants together. So I have 47 plus 2 is 49. 49 plus 15 is 64. 3x plus x is 4x equals 180. Subtract 64 from both sides. 4x equals, regroup, 116. Divide both sides by 4 to get that x by itself. And x equals, use my handy dandy calculator, 29. Now, I caution you, that's one of the answer choices. Don't get tempted to choose that one because we're looking for the full angle C. 29 plus 15 because what I found was x. So I need to add that to 15 and I get 44, which is C. Questions? All right, let's move on to the next problem. Jason is trying to figure out the perimeter of a rectangle that has a width of 5x minus 4 and a length of 2x plus 9. What is the perimeter of the rectangle that Jason is working with? What is the perimeter of the rectangle that Jason is working with? All right, so Jason's trying to figure out the perimeter of a rectangle. You know what we're going to do. We're going to immediately draw this rectangle. I don't know why I always draw my rectangles like this. You might naturally draw your rectangles like this. It's just not my natural. I don't know why. Neither one is wrong. It has a width of 5x minus 4 and a length of 2x plus 9. Now, I bet you're asking, well, what if I drew my rectangle the same as you, but then what if I did 5x minus 4 down here and 2x plus 9 up here? It doesn't matter. Here's why. Because area equals length times width. But multiplication is commutative, which means I can do multiplication in any order. So it doesn't matter if I do 2x plus 9 times 5x minus 4, or if I do 5x minus 4 times 2x plus 9. And perimeter is just the sum of all of the sides. Length plus width plus width. But addition is also commutative. So I can add in any order and it's not going to matter. So if you flipped them, it doesn't matter. What is the perimeter of the rectangle that he's working with? So I need to take this plus this plus this plus this. We know in a rectangle, opposite sides are equal. So that means that this is 5x minus 4 and this is 2x plus 9. So I'm going to do 5x minus 4 plus 5x minus 4 plus 2x plus 9 plus 2x plus 9. It doesn't matter what order you do it in. If you did 5x plus 4 plus 2x minus 9 plus 5x minus 4 plus 2x minus 9, it's not going to matter. We're going to get the same answer. Now I'm going to add my like terms. So 5 plus 5 is 10. 10 plus 2 is 12. 12 plus 2 is 14x. I'm constantly checking my answer choices. I'm constantly checking my answer choices because now I can be done with this problem. There is only one answer choice with an option of 14x. So I don't need to finish this problem. That's the trick for this math test. For any of these math tests, know what your answer choices are telling you and constantly refer back to them to see if you can find little clues embedded within, because there's no use in spending extra time on a problem that you don't need to spend extra time on. Now, I'll finish this out for you just to show you why it is the way it is, but I just want you to know you don't need to finish the problem. 9 plus 9 is 18. 18 minus 4 is 14. And 14 minus 4 is 10. So the answer is 14x plus 10. But we didn't need to finish that last 15 seconds, because 15 seconds plus 15 seconds on the next problem plus 15 seconds on the next problem, it really all starts to add up, doesn't it? So save yourself that time and don't spin your wheels on things that you don't need to spin your wheels on. All right, let's move on to the next problem. What can we conclude about the lines that are graphed to the right? Line A does not have a y-intercept. Lines A and B are intersecting lines that are not parallel or perpendicular. Lines A and B are parallel. Lines A and B are perpendicular. So the key vocabulary here is parallel, perpendicular, y-intercept, and intersecting. When we look at this problem, parallel lines never intersect. Parallel lines never intersect because they have the same slope. Are these lines intersecting? Yes, the intersection point is down here. So they're not parallel. I can automatically cross off lines A and B are parallel. They have an intersection point. I can also cross off A. Line A does not have a y-intercept. Line A does not have a visible y-intercept. This is the y-axis. This is the x-axis. Line A does not have a visible y-intercept. But I can imagine that as this line continues to extend, it's eventually going to cross that y-axis. So it absolutely has a y-intercept. We just can't see it. Just because we can't see it doesn't mean it doesn't exist. Now, I have to decide if they are not perpendicular or if they are perpendicular. Perpendicular lines have intersect at a 90-degree angle and have opposite. Actually, I should probably just say negative reciprocal slopes. So if line A is A over B, line B would be negative B over A for their slopes. So now let's figure out what their slopes are, and we'll be able to figure out if they are perpendicular. So I'm just going to rise over run. So from this dot to this dot, I'm rising 1, 2, 3, running 1, run 1, 2, rise 1, 2, 3, run 1. So rise over run. Line B, I'm rising 1, 2, running 1, 2, 3, 4. rise 2, run -4, rise 2, run -4. So these are not perpendicular. They are intersecting lines, but they are not perpendicular because 3/1 and 2/-4 are not the flip of each other. One is negative and one is positive, but if it was perpendicular, it would be 1/3, or it would be 3/1 and -1/3, or 2/-4 and 4/2. Those would be the negative reciprocals, and they don't match. So in this case, they are intersecting, but not perpendicular. Sophie is solving a system of equations and gets a result of 3 = -7. What does this mean for the system of equations? What does this mean for the system of equations? This means that the system of equations does not work and cannot be solved. This means that the lines represented by the equations are perpendicular. This means that the lines represented by the equations are parallel. This means that the lines represented by the equations are coinciding. So when she's solving a system of equations and gets a result of 3 = -7, if I have a system of equations, it means I have ax plus by equals c and another ax plus by equals c, and they're two different equations, right? So I have two lines coexisting on a coordinate plane. If I solve these two equations and I get an xy, it's showing me where those two equations are intersecting. So if I get x equals, 3, that means that the system of equations is intersecting at x equals 3. I can plug the 3 back in and find the y value. If I get 2 = 2, then that means I have the same line sitting on top of itself like this. But if I get a result like this, it means that there is no solution. When would there be no solution for a system of equations? When they don't intersect. So it would be something like this. What does that mean? That means that my lines are parallel. If my lines are perpendicular, then I'm going to get some sort of intersection point. If my lines are coinciding, then that means I'm going to get something equals that exact thing. And if it doesn't work and can't be solved, then I have like an impossible equation, like something's wrong. But if I get -3 = 7 or 7 = -3 or something like that, it's not possible, or there is no solution because those lines are parallel. So that's what it means. All right. I did receive some questions on YouTube Live a week or two ago of somebody asking for some very specific stuff. Do not think that I forgot about you. those questions are going to be included in next week's session. Sometimes I just have a backlog of questions that are requested or topics that are requested, and so those will be in next week's section. If you have any other questions that you want to see me go over, don't hesitate to let me know in the comment box or tag me on one of our Facebook pages, and I look forward to seeing you all next week. I hope that you have a great rest of your week. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.